Hello and welcome to the CIBSE West Midlands Region CPD webinar on an introduction to plant room surveys. Today's event will cover an introduction to the various stages involved in surveying a plant room, with particular focus on surveys for retrofit boiler installations. This includes access, risk assessments, pre-survey checks, and finally brief information on the best practice of commissioning. This seminar is designed for mechanical and electrical engineers, building services engineers, building contractors and consultants. Our host today is Michael Fraser, who is a Specification Manager for Ideal Commercial Heating in the Midlands. He has 21.5 years in the industry, 18 of them as an estimator, senior estimator and area sales manager in the commercial flue industry, and 3.5 years as a Specification Manager for Ideal Heating, assisting consulting engineers in the Midlands with selection and design of their range of commercial boilers, air source heat pumps and heat interface units. We thank Michael and all of the colleagues at Ideal Heating for their help and support in today's event. Just a few housekeeping tasks before we get started, if I may. Please keep your microphones and cameras switched off unless you'd like to ask a question, but bear in mind that this session is being recorded and will be made available on various social media platforms, including YouTube and our podcast, for people to catch up with afterwards. Alternatively, please use the chat function to ask any questions during the presentation. Please contact Michael direct for a copy of the presentation slides after the event. Contact details to follow. Please get in touch by emailing cpd@cibsewm.org. That's cpd@cibsewm.org for any CPD certificates stating your name, the subject of the event and the date, and they'll be emailed to you afterwards. I'd like to take the opportunity to thank you all for joining us for today's session, but also thank Michael and the team for sharing with us today too. I'm really looking forward to it. Michael, over to you.
Thanks, Joss. So, like Joss said, my name is Michael Fraser. I'm Specification Manager for Ideal Commercial Heating in the Midlands, and I'm going to present a CIBSE accredited CPD on an introduction to plant room surveys. So, contents, we're going to look at the assessment of the plant room, the existing plant room for things like safety and what existing plant is in situ, etc. We're going to look at the replacement, so what is required to replace the existing plant efficiently, and commissioning, so what would need to be in place and what would be carried out, etc., to achieve sign-off. So learning objectives, this is all important as there are risks attached when surveying an existing building. So we will look at the plant room assessment and the requirements for replacement heat source, identifying the potential risks associated with the heating system replacement, the importance of pre-survey checks, including ventilation, flue system, system water quality, boiler protection, identify the system type, existing boiler plant, circuit types, controls, fuel supply, condensate drainage, and basically understanding the best practice of commissioning. So applications for retrofit. Retrofit is completely different to new build. A new build is a completely new design on a completely new building based on basically known factors. However, a number of things need to be considered when looking at applications for retrofit, as there will usually be unknown factors which need careful consideration. So a plant room survey can help avoid issues such as plant oversizing and highlight improvements such as efficiency, savings, etc. So your existing plant may be 20 to 30 years old, and it was common to oversize requirements back then. So, and also the building fabric may have changed. It could have new windows, for example, giving better insulation. Also, the building requirements may have changed. The boilers may not be serving all parts of the building as they have been before. So you may be able to downsize your plant. Installing new condensing boilers as part of a replacement or retrofit program can aid space creation in a plant room or allow for a change to building floor plans. Condensing boilers can often provide similar outputs in a smaller area. So, for example, you may be replacing two old 300 kilowatt large floor standing pressure jet boilers, but you can now put 600 kilowatts on a frame or on a wall. So this could free up a lot of space in the plant room for your client. So initially, the specifier would need to carry out a plant room assessment. The process involved and the areas to be explored are covered over the course of this session. Risk assessment. This is always a good idea. Like I said, as you will be first on site to assess, and your findings can be passed down the line. Stage 1 involves carrying out a risk assessment of the existing plant room. This will give all parties involved, design consultant, client, contractor, merchant, the information they need. This should include accessibility for products, measurements and dimensions of door, plinth, room, lighting, is it adequate, creating a safe environment to work in? Noise levels, would ear defenders be required, or are there specific noise constraints that need to be taken into account within your retrofit design? Environmental conditions such as floor conditions, slip hazards or trip hazards. Is a site induction required? You need to look at the asbestos register. This needs to be checked before you even enter the plant room. I've always found this readily available at most sites, and if it isn't, you need to request one. Is PPE needed? Would road closures be required? Is crane or lifting equipment required, and are there any weight loading restrictions? So the plant room may be on the roof of the building, and there may be a service lift to take the new plant up to the plant room. However, on closer inspection, the lift may not be able to take the loads of the new plant, so then you may need to look into craning the new plant onto the roof. And with this, to site the crane, you may need to organise road closures. All very important to be looked at this early stage. Survey checks. It is important to categorise the scale of the project to identify whether it requires a complete redesign or just specific changes and/or upgrades. Following the risk assessment, the specific boiler requirements should then be considered. The following questions should be asked: access route to the plant room, site delivery through to plant room, will the replacement equipment fit in the plant room? So this was mentioned on the last slide. There have been plenty of occasions, as I'm sure you're aware, where a project has got to install stage and the installer can't get the specified plant into the say a basement plant room. I've personally been involved in a project where the specified floor standing boilers would not fit around a corner at the bottom of the basement plant room steps. We were asked if there's anything we could do, and a bank of our frame mounted boilers were eventually installed, a problem that could have been identified and prevented at a very early stage. So what type of controls are required? Do the existing controls need assessing? Is there a BMS that you can reuse? Do you need assistance with controls that can be supplied by the boiler manufacturer? Are existing boilers running? Are the existing pumps running? This can be a challenge if your client needs to keep some of the existing boilers running throughout the replacement. So you have to think about phasing of the works to enable this. Clearances, all boiler manufacturers specify on their data sheets the clearances required for maintenance, and these need to be adhered to. So basically, to sum this up, a risk assessment will help with boiler selection for the replacement. So this wasn't originally on the CPD, but I mean this CPD it's a few years old, so I think we need to mention heat pumps. So it's the CPD is primarily about retrofit plant rooms, and there are obviously a vast number of boilers being replaced by heat pumps. So I've just made a quick list of things that need to be considered when replacing boilers for air source heat pumps. So is there adequate space externally to site the heat pump or pumps? Heat pump manufacturers' data sheets need assessing for spacing out requirements, whether installing one or a bank of heat pumps. Is there ground for them to be sited on in good condition? Is external noise going to be an issue? Will attenuation be required? Is there an adequate electrical supply to site for the heat pumps, and does, for example, three-phase need introducing? A full heat loss calculation needs to be carried out, as due to the efficiency of heat pumps, it may not be just a case of allowing the same load as the existing boiler load. Is the building insulated correctly, and are improvements required to enable heat pumps to become a more viable option? What are the existing flow and return temps? Will the heat pumps operate at the existing temperature differentials? Do pipe work and emitters need altering? Do you have room to site the relevant buffer vessels, etc., in the existing plant room? Like I say, just a few things to consider, as this is a CPD focusing on primarily retrofit plant rooms, so I feel that it's relevant just to mention the heat pumps. Survey checks. So this is just a brief outline of legislation, as they do change quite often. If you're replacing under 400 kilowatts, ERP efficiencies must be met for new boilers. And if you, for example, if we're asked to replace a pressure jet boiler under 400 kilowatts, we can only supply parts, not a completely new boiler. So the equivalent condensing type may have to be considered. And plant rooms over 400 kilowatts, obviously subject to building regs part L. Now this one's an interesting one. Plant rooms over 1 megawatt are subject to the medium combustion plant directive. I've done this CPD quite a few times, and a lot of people aren't aware of this. But if you're doing a boiler replacement and you're installing any one boiler 1 megawatt or above, you have to apply to the local environmental officer for approval to do this, and this is the MCPD. Now, it is actually down to the plant operator to do the application, but it could be too late when it gets to that stage. So it may be something you want to look at in before the project gets too far down the line, and it could become an issue. It was the same when I used to do flues. Every flue had to be approved by the local environmental officer. Very rarely it was. And sometimes it came to installation stage and it became an issue. So the MCPD is something, if you're not aware of, you may want to look into if you get involved in projects where you're going to install any one single boiler above a megawatt. If you've got if you're replacing 4 800 kilowatt boilers, sounds a bit ridiculous, but it doesn't come into play. It's just if one of the boilers is 1 megawatt or older or over. So this is just a schematic for reference to remind you of a few things that may need including within your designs. For example, you might be including a plate heat exchanger for 100% hydraulic separation for your boilers. However, you may still need to consider, say, a strainer or a magnetic filter on the system side, as the plate heat exchanger itself could get clogged up, and this will help prevent this. Like I say, this isn't a working schematic, it's just for reference, and there's a few things on there just as a reminder. So the importance of plant room ventilation. So anything burning fuel needs plant room ventilation. There are some tables on this slide, but for more in-depth information, please refer to BS 6644 and IGEM UP10. So plant room ventilation will influence equipment and boiler selection when working on applications for retrofit. The ventilation areas will need calculating to enable accurate specification. And obviously, poor ventilation could lead to reduced performance of your plant and affect the longevity of the product's life. So as I said, guidance for ventilation can be found in BS 6644 and IGEM UP10. Areas to be identified should include: is the current setup mechanical or natural? Is the ventilation adequate for the proposed plant? And also, is the existing ventilation adequate for the existing plant? Don't just assume it is. And I'm sure a lot of you'll be aware, if you walk into a red hot plant room, then straight away it should ring alarm bells, because there may be issues with the existing ventilation. Mechanical ventilation, is it required to be interlocked with the boilers? So if the ventilation falls, the boilers shut off, obviously. And the air source must be taken direct to outside, sometimes a bit of a contentious issue, but for example, ventilation can't be taken from a corridor, even if it is ventilated. It needs to come from directly from the outside. There's quite a few slides on flues now. I'm not going to dwell too long on some of them because there's a lot of information on there that will need to be assessed job by job, and it'd take me forever to go through it. But on this slide, it is vitally important to ensure that flue gases are terminated safely. And flues can often be one of the biggest head scratchers during design. I can tell you that through experience. So legislation and guidance, IGEM UP10 and BS 6644. So existing flue system checklist. Is it an open flue, type B, or room sealed, type C? Consider existing dilution system may be used, or maybe you can install a new flue dilution system. Anybody not familiar with the flue dilution system? It's connected to an external wall, the intake, onto a louver, and the ducting goes round, picks up the boiler flue connections, and then on the exhaust side there's a fan, and that dilutes the flue gases to less than 1% CO2 to enable them to be discharged horizontally. It then goes back to the wall, to the exhaust louver. Can be a very good way of getting your exhaust gases out if you can't take your flues to roof, but there's also a lot of things that need taken in consideration with the flue dilution system. For example, they plume like crazy on condensing appliances. Many a time the fire brigade have been called when it's just been a flue dilution system discharging on a cold day. But like I say, there can be a good get out if you can't get your flues to roof. You need to look for a suitable terminal location. You need to select the correct steel, which is usually grade 316 stainless steel on the new condensing boilers. You have to look at the sizing. If you're thinking of using the existing flue, you need to look at the condition. You need to look at the route of the existing flue for resizing. But a lot of these things will be picked up by your flue specialist, which you'll need to get involved when designing your new flue system, and they'll decide if the new flue needs draft stabilizers, dampers, and condensate drainage will be required due to the acidic condensate, and it produced by condensing boilers, and they produce a lot. So there are all sorts of minimum distances to take into consideration when looking at flue termination. There's too many to go through on this slide, and again, please refer to IGM UP10 and BS 6644 for further information. Flue system checks, like I said, again, this slide, it relates to the last slide to help work out flue termination positions. It's taken from IGEM UP10, so please refer to that for further information. I'm not going to go through all the distances on there because it's a job by job reflection. Flue system checks, type B open flue. Before ventilation can be sized, the type of flue system needs to be identified. Below are a few examples of boilers with and without draft diverters. Very rarely would you install an appliance with a draft diverter nowadays. And your flue manufacturer will help specify the correct type of flue based on the boiler manufacturer's literature. Flue system checks, type C, sealed flues. So the table below highlights different kinds of sealed flue systems. However, in nearly all cases, if you're going with a sealed flue, this will be supplied with the boiler. Excuse me, and the boiler manufacturer will select the correct type. Couple of points to consider, not related to type C flue actually, they're actually relating to type B. Where two or more gas-fired boilers are connected to a common natural draft flue, the boilers must be installed in the same room and have the same type of burner system. A gas-fired boiler and a solid fuel or biomass boiler must not discharge into the same flue. A gas-fired boiler and a liquid-fired fuel boiler can discharge into the same flue, providing they are both installed in the same room and are forced draft. Excuse me again. So moving on, System water and hydraulic checks. The first thing that gets neglected as the plant room is passed down the line, as I'm sure you'll all know, is the water treatment. Water quality can have a big impact on the existing and new heating system. Checks should be carried out to identify current and future requirements. This can be logged by completing some system water checks. So, is there any evidence of water treatment system? Do you need to take a water sample? You can actually take a water sample and give it to us if we're getting involved, and we can send it up to our Hull HQ. They work with a water treatment company and the University of Hull, and they can give you an independent assessment of your water treatment. So is there a dosing pot? Obviously, if you need to pour inhibitor in after your yearly checks. Is there magnetic filters? Do you need magnetic filters? Is there a plate heat exchanger? Do you need a plate heat exchanger to protect the boilers from the secondary system? And are you going to be looking at a dirt or air separator or a strainer? System information. So you need to look at the boiler primary pump make and model. Can it be reused? No reason why not sometimes. Is the existing system sealed system or open vented? So if changing from an open vented to a sealed system, then obviously the pipe work will become pressurized, and which it hasn't been before, and it may leak, and this needs to be assessed. Feed and expansion tank height. Boilers need a certain amount of pressure to operate, so they will need to be a certain height. Sorry about this. Is there a pressurization unit? What's the model of it? Is it interlocked? Look at the expansion vessel size and volume. Look at the existing cold feed. And the static system head. This is most important, as we need to know the pressure in the plant room. Our maximum for our appliances is 6 bar. So if you've got a tall building and a basement plant room, this could become an issue. So then you can look at using a plate heat exchanger, or even multiple plate heat exchangers on different floors, as they can take up to 40 bar. Existing boiler plant, will it be a like-for-like replacement? So as highlighted earlier, a like-for-like swap is not usually the best option for a retrofit application. The existing boiler setup should be analysed to allow for the correct selection for replacement, which should benefit efficiency and reduce running costs. So basically, your existing boiler could be 85% efficient. Your new one could be 95% and upwards. So this could result in a 10% reduction in running costs if you select your plant correctly. Just a note, I get this quite a lot. We can help identify existing boiler makes and models. If you're ever in a plant room and there's just nothing on the boilers to tell you what they are, if you take some photos and dimensions, we've got some people up in Hull that relish the chance to have a go at this. They seem to know every boiler model that's ever been made, so we can get you out of a bit of a hole there. So then you need to look at, is the current boiler provision adequate? What's the current boiler input or output? Again, we can help you with that. Number of boilers and total load. What's the boiler type, the make and the model? The burner output and the make. The fuel type, is it natural gas, LPG or oil? And does the boiler meet current legislation? A lot of the time now it doesn't. Boiler system checks heating. Once the system water and existing boiler plant has been considered, the system check for the heating should be carried out. This includes identifying correct characteristics such as checklist, hydraulic bypass, separation. Do you need a low loss header or a plate heat exchanger? Reverse return. A lot of banks of boilers now, including our own, can come with our own header kits, plate heat exchangers, shunt pumps. If you're not allowing for that, you might want to look at a reverse return arrangement if you're using your own pumps to help balance the system. Header and system configuration. Drain suitable for condensing applications. As I said before, the acidic condensate needs routing to a suitable drain. Is there a suitable cold main? Is there a pressure relief valve fitted? What are the existing circuit temps, flow and return temps? What's the existing delta T? Is there a boiler thermostat setting, minimum, max? And the circuit types, is it constant temperature or variable? All of the above will help design the replacement system. However, the information is not always available on site. Other places to source this information are commissioning reports and recent service reports. So boiler controls, existing and future. Any setup of controlling the system and requirements will be imperative during this stage of the process. Again, the existing setup should be analysed to allow for the best solution going forward. Checklist. Is there a BMS controlling the boilers? Is there a boiler sequencer? Is there a room temperature sensor? A programmable room sensor? Is there an external air temperature sensor? Is there weather compensation? Is there a calorifier temperature sensor? So you need to collect as much information as possible to help ensure the replacement boilers have the correct functionality. Again, commissioning reports and recent service reports may help this. Existing domestic hot water plants. There's nothing new to mention on this slide. It's all the exact same things as when you're looking to replace your boilers. All I'll say is a bit of a plug for us personally. Anybody who doesn't know, we work closely with a company called ACV, who are our sister company, and they specialise in domestic hot water plants. So I can offer you advice on that as well when it comes to it. But there's nothing new on this slide. It's all the same checks and to make sure that you replace correctly. Fuel detail. Further to the assessment of the existing boiler and domestic hot water plant, a more in-depth approach to the fuel type of the site should be carried out. This should look at, again, the fuel type, natural gas, LPG or oil, the gas meter size. As you all know, you need to check that that's adequate for the new plant. The current oil type or upgrade, is it 35 second, 28 second or biofuel? The size of the oil tank, is it still adequate? Is it dual fuel and or the type of fuel? And is the fuel delivery access still accessible? Well, it should be if it's running at the moment on fuel oil. So, but it's still something to check. All these things are important. If we are replacing a pressure jet boiler with a pressure jet, we need all this information to allow for the correct new burners, because there are different types of burners for different types of fuels. Gas pipe checks. Never assume the existing gas pressure is okay. Old boilers are far less sensitive than modern boilers, and generally new boilers require a higher gas pressure. So you need to check, have you got visibly marked and bonded pipe work? Is there a gas shut-off valve within the plant room? Check the diameter of the gas pipe work and the total length, the quantity and variety of fittings, and check the gas supply. The last three I mentioned on that list, that will determine whether you've got adequate gas pressure or not. Pumps, can we use the existing? First of all, we need to identify if the current system uses constant or variable flow pumps, and if the existing pumps are suitable for the existing plant and the new boilers. There is no reason the existing can't be used if they are of the correct size and in good condition. The following should be assessed. Is the pump capable of delivering the max required flow rate against the required pressure drop? Can the pump operate at up to 115% of the required flow rate? And for variable, what method is used to control pump speed, i.e. differential pressure, control valves or temperature control? Identify the max turn down on the pump speed. So if you are using the existing pumps, but if they won't turn down enough, you'll lose some of the boiler modulation that you're getting with your new condensing plant. For example, everybody's shunt pumps usually modulate with the burners, so if you do use the existing, you will lose this capability. and identify if the pumps are connected to the BMS. So replacement considerations, a summary. You've got to look at legislation around BS 6644 and IGM UP10. And IGM should also be taken into consideration, especially the amount of ventilation that is needed for the safe running of a boiler. We must meet current regulations. The obvious checks need to be considered: clearance around the boiler, which should always be in line with the manufacturer's guidelines for servicing and commissioning checks. Service and access should never be restricted. Identifying the safe parameters within the legislation should always be checked with a flue installer, designer or manufacturer. M&E contractors and building service managers looking to maximise space within the plant room have a checklist of utilities to consider. Heating systems are just one of many to juggle. Boilers in particular are just one piece of the plant room jigsaw that needs to slot into place. With strict guidance and legislation around the area required for ventilation, access for handling units and clearance in line with the manufacturer's guidelines for maintenance, for example, it is a headache for many. So consideration: short-term, access, siting and installation; long-term, ensuring access for future service and maintenance, and longevity and performance of the boilers. So commissioning. Boiler commissioning can be a time-consuming process for both the engineer and the end customer, especially as there are several steps to carry out. Nevertheless, it's a vital stage in any commercial heating project to ensure optimum efficiency levels. So best practice should include: method statements and risk assessments have been put in place, plant room is in a clean state, control valves are present and correctly positioned, electrical checks to pumps and boilers, system is filled, treated, vented and circulation achieved, fuel system is purged, PRV set and active, approved flue installed, clear and insulated where required. Believe it or not, we have turned up to commission before and the people have forgotten to get the flue installed. Control systems operational, boiler room ventilation is proven and available, initial boiler firing, system performance reading, high and low combustion readings, working gas pressure, hydraulic flow return and temperature differentials, flue performance checks, and a commission input report will be issued if all the above are adhered to. So thanks for listening, and if anybody's got any questions, please ask. That's not me in the boiler suit. We're proud sponsors of West Bromwich Albion Football Club, even though I'm not a fan of them, and that's their mascot, Boilerman. And my details are on this slide if anybody would like to get in touch. Thanks for listening.
Excellent, Michael. Thank you very much for that. Really interesting and informative. Thank you very much. Just while everybody's gathering their thoughts and questions, maybe I've just popped a link in the chat to some of our future events and our YouTube channel for those that weren't able to join us today. Please share that with your colleagues. Our next event is being held on the 10th of October, which is a CPD session titled Designing with Innovative Steel-to-Steel Connections and Support Solutions for Bracketry and Supports. And then following that, we've got another event on the 17th of October, which is all on fire dampers, titled No Smoke Without Fire. And then the following day, we've got a bumper crop of Meet the Committee over at the Edgbaston Stadium. Meet the Fellows for anybody that's looking to find out more about fellowship or becoming a fellow. And then in the evening, we've got a BS 7671 wiring regulations, an overview of the top 10 changes of the wiring regulations event, all on the same day at Edgbaston Stadium. You can sign up to attend and benefit via our Eventbrite page, details in the chat. You can catch up with our events by subscribing to our YouTube channel, and any feedback, thoughts and comments are welcome by emailing feedback@cibsewm.org. I'd like to take the opportunity to thank everybody who's joined us for doing so. It was great to have you with us today. Thank you very much. I'd also like to thank Michael and the team at Ideal, along with the team behind the scenes too, that have made today's event possible. Thank you all very much. I look forward to welcoming and meeting you at a future CIBSE West Midlands region event in the near future, and I wish you all for the rest of the day. If anybody does have any questions or comments or anything, then please feel free to ask them now. So just a few chats in the chat, Michael, just saying thank you all very much. So I guess that that will be it for today. Thank you all very much, and have a good remainder of your day.
Yeah, thank you very much, and apologies for the coughing fits. Don't know where that came from.
It's par for the course at this time of the year, isn't it, really, with coughs and sneezes, unfortunately, but no problem. Thank you all very much.
Yeah, I hope you all took something from it. Thank you for attending.